So what we do is divide the domain. The domain is, of course, so we divide this entire domain in two elements. So this is node 1, node 2, node 3. This is element 1, element 2. So we have connectivity array, mesh connectivity data. So element, node I, node J. Element 1, node 1, node J is node 2, element 2, node I is node 2, node J is node 3. So right hand side node and left hand side node and the right hand side node for element 2. So this is x is equal to 0. This one is x is equal to L by 2. X is equal to L by 2. The nodes are defined by their coordinates. X is equal to L. Right? So we can have, again, the process is exactly identical. The governing differential equation remains the same. It's just that the weighted residual statement is given as sum of the weighted residual statements over two elements. So we have, let's take element 1. So weighted residual statement right? So the weighted residual statement over the entire domain is given as weighted residual statement over element 1 omega 1, that's the domain of element 1, plus weighted residual statement over the domain 2 omega 2, domain of element number 2. And these are all, both of them are independent of each other. That's important to note. Whatever we do in element 1 is independent of whatever we do in element number 2. So these statements can be treated independently of each other, and then the contributions can be added up to make up the whole. Right. So considering omega 1 or element 1. So u hat over element 1 is given by u1 n1 okay, I would just say ui nix plus uj njx. And what is ni? Ni x is equal to x minus xj. Xj here is L by 2 divided by xi minus xj. So xi is 0 minus L by 2. So you have L minus 2x by L. Right? And if you see at x is equal to 0, this evaluates to unity. At x is equal to at x is equal to L by 2, this evaluates to 0. Similarly, nj will be equal to x minus xi divided by xj minus xi. So this is equal to twice x by L. Right? Now, if this is ni nj, the interpolation is defined, so we can always find out what is dni, because this will be required for the weak form. So dni by dx is equal to minus 2 by L and dnj by dx is equal to 2 by L. With this, we can write the weighted residual statement. 0 is equal to integral w d over dx ae du by dx xi to xj plus xi to xj w, what is it? Okay, w naught by L, L minus x dx. dx. So we can evaluate the weak form, develop the weak form, and we have w multiplied by ae du by dx at xj minus w a du by by dx at xi plus minus integral xi xj dw by dx ai ae du by dx dx plus integral xi xj w L minus x dx. So now let W is equal to Ni to begin with. Then dW by dx will be equal to minus 2 by L. So Ni will evaluate to 0 at x is equal to j, so this term will vanish. Ni will evaluate to unity at x is equal to xi, so this term will remain. So we have minus ae du by dx at xi minus, now dw by dx for w is equal to ni is going to be minus 2 by L and du by dx is of course is equal to u2 minus u1 divided by L multiplied by 2 plus q naught L. W is equal to Ni, so this is going to be L minus 2x by L L square. So what do we have here? Minus ae du by dx at xi minus 4 L square zero L by 2 u2 minus u1 dx plus q naught L square 0 L by 2 and this is L square minus twice Lx minus Lx, so minus 3 Lx plus 2x square dx. So this is zero is equal to minus ae.
So in the second term, AE should also be there.
Yes. Thanks. Plus 4AE L square multiplied by U2 minus U1 L by 2. I mean, this will be x, and this is evaluated at x is equal to 0 to L by 2 plus Q naught by L square multiplied by L square x minus 3L x square by 2 plus 2x cube by 3 at x is equal to 0 to L. So let's evaluate the limits. So we have AE du by dx at xi plus this will be L by 2, so 1L cancels here, 2 factor 2 cancels there, so 2AE by L multiplied by U2 minus U1 plus this requires a little bit of calculations. So this one is straightforward L cube, this one is 1.5 L cube, this one is 2/3 L cubes. Right, so what happens? 6.
Sir, limit should be 0 to L by 2 now.
Yes. Sorry. It should be 0 to L by 2. That's right. Everything changes now. So, this becomes L cube by 2 minus 3 L cube by 8 plus 8 choice L cube by 12. Yes?
The whole term will be Q naught L.
Q naught?
Q naught L.
No, I am not able to get it. What are you saying?
After calculation.
Okay, anyway, let it be. So this is 5 by
5/24 Q naught L.
Q naught L 5 by 24. Okay, fine. Thanks. Saves me the trouble. A by L U2 minus U1. xi is equal to 0, so this is x is equal to 0. So that's the first equation for using W is equal to Ni, and we can get similar equation if we choose W is equal to N2. W is equal to Nj x. So that means dW by dx is equal to 2 by L. And we have the expression 0 is equal to, now we will have Nj unity at the, so AE du by dx at x j minus four AE by L square u2 minus u1 dx 0 to L by 2. I think that was it. u2 minus u1 L by 2, so fine. And this one would be q0 by L plus q0 by L square integral 0 to L by 2 x multiplied by L minus x dx. Is that 2x? Isn't it? What is Nj? Nj is 2x by L. So when we multiply here 2x by L, so that would be q naught L square multiplied by 2x, or 2L, 2x multiplied by L by x, L minus x. So that is fine. So we can write this as 2q naught L squared multiplied by L x square by 2 minus x cube by 3, 0 to L by 2. So this term will be equal to 2q naught L square multiplied by L cube by 8 minus L cube by 24. Right? So this is equal to so 4q naught L by 24 qL by 6. So you get the equation AE du by dx at L by 2 minus 2AE by L u2 minus u1 plus q naught L by 6. That's the second equation. So let us collect the terms. We have 2AE by L, 1 minus 1 minus 1 1, u1 u2. Well, somewhere I started using 1 and 2 for I and j, but in this element it doesn't matter. Is equal to the first equation 5 q naught L by 24 minus AE du by dx at x is equal to 0, and here it is Q naught L by 6 plus AE du by dx at x is equal to L by 2. So this is equation, first element equation. Element 1 equilibrium equation. Let us set it aside. Now let us work with element number 2. So for element number 2, weighted residual statement for element number 2. So element number 2 is defined by nodes 2 and 3. Local coordinates, local node numbering, we call it I and j, but in the global mesh, node I for element number 2 is mapped onto node number 2 in the finite element mesh. Similarly, node j for element number 2 is mapped onto node number 3 in finite element mesh, and xi here is L by 2, xj here is L. So the weighting function, the interpolation function ni is equal to x minus xj divided by L by 2 xi minus xj. So that gives you minus 2 minus L twice L minus x by L, and nj is equal to x minus xi divided by xj minus xi. So this is equal to L by 2, 2x minus L right. So at x is equal to L, this is equal to 1. At x is equal to L by 2, this vanishes, nj vanishes. Similarly, at x is equal to L by 2, this is equal to 1, and at x is equal to L, this ni vanishes. And similarly, we will have analogously ni dni by dx is equal to minus 2 by L dni dnj by dx is equal to 2 by L. So you can see the similarity here. Although the elements are different, the interpolation functions they are linear, but obviously they look different because they have to satisfy the interpolation condition at different coordinates, but the derivatives are all identical. ni, dni by dx is still minus 2 by L, dnj over dx is still 2 by L. And if we look at it to the W ni, so we will have interpolation function minus ae du by dx at x is equal to xi minus four ae by L square that dni by dx is negative 2 by L, so that's why this becomes positive here. u2 minus, sorry, not u2, this will be u3 minus u2 dx L by 2 to L plus q naught over L squared integral L by 2 to L twice q naught L minus x multiplied by, what was it? L minus x? L minus x. Okay, fine. So let us evaluate this. It will lead to twice ae by L u3 minus u2 this would be integral, so x L minus 2 L by 2, so that would be L by 2 and that will convert this to 2 by L and this will be L squared minus twice Lx plus x cube x squared, so L squared x minus L x squared plus x cubed by 3. So this is equal to twice q naught by L squared multiplied by L squared x Lx squared plus x cubed by 3 between x is equal to L by 2 to L. So this will take little bit of problem. So let's say L cube minus L cube plus L cube by 3 minus L cube by 2 L cube by 4 L cube by 8. So this is 8, so this becomes 4 minus 2 plus 1 5 3 8. So 3 L cube by 8 and this one is of course L cube by 3.
last one will be L cube by 24, na, sir.
Pardon? L cube by?
24, sir. 18
Oh
by
yes,
24.
this would be 24. Right. करो भाई कैलकुलेट. So this is 12 minus 6 plus 1. So this is 7. 7 by 24. So you have L cube by 3 minus 7 L cube by 24. Right? So 8 minus 7 is 1 by 24. Fine. So this is Q naught L by 12. All goes. So 0 is equal to minus AE du by dx at x is equal to L by 2 plus twice AE by L u3 minus u2 plus QL by 12, right?
Yes, sir.
Okay, fine. So that's one equation. Now if we choose W is equal to Nj, we will have another equation.
Sir,
Yes,
sir, I'm getting 3 by 8.
you are
Q
getting
naught L.
3 by 8.
3 by 8 Q naught L.
3 by 8 Q naught L. Okay, fine. I don't just cross check which one is correct until I finish this thing. So other equations would be of course identical. We will have AE du by dx at x is equal to L minus twice AE by L multiplied by u3 minus u2, and there would be only this term Q naught by L squared integral L by 2 to L. This one would be Nj here is 2x minus L. 2x minus L multiplied by L minus x dx. So this is equal to twice Lx minus L squared minus twice x square plus Lx. So this would be 3Lx, and its integral is going to be 3Lx square by 2 minus L square x minus 2 x cubed by 3. So let us see how this works out. 3 L cube by 2 minus L cube minus 2 L cube by 3 3 L cube by 8 minus L cube by 2 minus this 2 L cube by 24. So maybe L cube by 12. To L cube by 24, that is easier. So this would be 24 9 12 minus 2 14. This one is 6 9 minus 6 4. Minus 1 by 6 plus 5 by 24. Fine. So this is Q naught L by 24. That's all. So this is the second equation. U3 minus U2 AE du by dx at x is equal to L. So we can collect the terms and we will have 2AE by L one minus 1 minus 1 1 U2 U3 is equal to minus AE du by dx at x is equal to L by 2 plus what was it? QL by 12. And here we have AE du by dx at x is equal to L plus QL by 24. That's the equilibrium equation for element number 2. Now, the next step that is left is to assemble these contributions. So these are the weighted residual contributions from individual elements. So we have, if you look at this, so we have evaluated this, that is reflected by the equilibrium equation from element 1, and we have looked at this is the reflected by equilibrium equation for element number 2. Now we need to take care of this assembly operation. Assemble the contributions from element 1 and element 2 to get an approximation over the whole domain. So we will do that in our next lecture. Thank you.
Sir, hello.
Yes.
Sir, what will be the syllabus for our midterm?